Measure of dispersion for ungrouped data with frequency. Okay, so before this we have discussed about the measure of dispersion for ungrouped data. So right now we are going to discuss for ungrouped data with frequency. So the formula we have for range, the largest value minus with the smallest value. So for ungrouped data with frequency, if you look at table example 2.45, so if you remember, this is how ungrouped data with frequency looks like. So we have the number of absent days. This is x variable. So variable x, and then we have number of student, frequency f. So the largest value that we have here is 3. So the smallest value that we have here is 0. Therefore, range equals to 3 minus 0. Final answer is 3. So for interquartile range, under the assumption that you already calculated the value for quartile 3 and quartile 1, so in example 2.46, the quartile 1 and quartile 3 is already given right here. The value is already given, so you only have to calculate IQR according to the formula. Quartile 3, which is 75, minus with quartile 1, 53.39. So the final answer that we are going to get here is 21.61. So this is the interquartile range, or the difference between the quartile 3 and quartile 1. And then for formula number 3, we have quartile deviation. Quartile deviation is not affected by extreme value, but then since we are only discussing about quartile 3 and quartile 1, we only discuss about the 50% of the distribution, and another 50% are ignored. So this is quartile deviation. So based on the formula and the values given right here, quartile deviation equals to 75 minus with 53.39 divided by 2. So you're going to get 10.805. So this is quartile deviation. So the last formula for measure of dispersion for ungrouped data, we have standard deviation. So for standard deviation, we are going to discuss together with variance. So we have formulas here. The first formula is for standard deviation. Standard deviation, the symbol is S. And then for variance, the symbol is S squared. So the formula that we are going to use is this one and this one. Okay, so since in the formula, we need to find the summation of fx and the summation of fx squared. And then the value for n over here is actually the cumulative frequency. So in example 2.48, calculate the standard deviation for the following data. So we have number of absent days. First of all, this is x, and number of students. The symbol is F, stand for frequency. So the first that we have to find is cumulative, the value for F multiplied with x. So you need to multiply. So the first one, 20 multiplied by 0. So any numbers multiplied by 0, you're going to get 0. So 21 multiplied by 1, so you are going to get 21. 15 multiplied by 2, so this is 30. 10 multiplied 3, this is 30. So the symbol for cumulative fx equals to 30, 30, 60, 81. So this is for cumulative fx. So next we have to find the value for cumulative fx squared. Fx squared. So 20 multiplied by x squared, 0. 21 multiplied by 1 square, so 21. So the next number, 15 multiplied by 2 multiplied by 2, so you're going to get 60. So 10 multiplied by 3 multiplied by 3, so this one 90. So if you total everything, so you're going to get 90 plus 60 plus 21. So the answer is 171. So after that, you need to replace this value into the formula. So we have this one here, cumulative fx squared. This one is cumulative f. So if you don't know how, this one is actually 10 multiplied by 3 multiplied by 3. This one is 15 multiplied by 2 multiplied by 2. Okay. And then you square root the final answer, you're going to get 1.0495. Although, please remember, 66 is actually cumulative frequency. So where do you get this value? It's over here, cumulative f. So 20, 21, 41, 51, 66. And then for L square, you just simply, you don't have to square root the value, so you're going to get 1.1014.